if you take all the water that we use, all of us all together collectively, we use 59% of that water for irrigation.
Wow.
Cities have to produce water. And so a lot of people don't think about this, but you just turn on your faucet and the water's there, right? The city engineers are looking at, I've got this water treatment plant and it's producing this many millions of gallons of water a day. Now we're looking at population growth. Can we keep up with it? When do we need to start thinking about bringing on a new water treatment plant? We're at capacity, but all the water we're drinking is already recycled. All the water that goes down your drain goes back to the city. They filter everything out, and then they sanitize it, chlorinate it, and then they send it back to us. And then you drink the recycled water.
Right.
And so, Rainwater kind of goes and cuts that off instead of taking the water and sending it to the city, and then they sanitize it and sell it back to you. You're collecting it at the source and using it at the source, which is your house or your business.
Zach Gavos, I'm so glad that you're joining us today. I've been trying to get you on the podcast for a while now, and you've been working on a new website for Droplet Resources, and you're like, hey, let's just hold off a little bit until we get the website in place. And so now it's all out there, and you're here, and I'm so glad to have you. So thanks for coming.
Yeah, thanks for having me, Curtis. I really appreciate it. Danielle has been emailing me every once in a while going, hey, are you ready? No, not yet. Almost there. So glad to be on. Excited about it.
Yeah, I'm really excited about this topic. I think it's something that's going to resonate well with our viewers and listeners, and it's something that people are interested in. There's a lot of stuff going on, not only in Texas, but around the country that makes, water conservation, water reuse, just a hot topic. And so I'm really excited to be talking about it today.
Yeah, thanks.
So tell us just real quick about yourself. And you also have a home building company. You're on the Custom Builders Council board with me at the GHBA. So you do that as well. But how did you kind of get here into doing Droplet Resources?
Yeah, so I've been in construction for 18 years. Started building houses 18 years ago. First got hired by a national volume builder, went through their training program. That's where I learned how to build a house. That's where I fell in love with construction and building houses, and worked for them for 3.5, 4 years. That's when I knew I wanted to have my own business one day. So my home building business is Keepsake Custom Homes. We do new custom homes, remodels, additions, and historic renovations, mostly in Galveston. That's where we're based out of, but also a few houses in the Houston area as well. And so worked for the production builder, the volume builder, for 3.5, 4 years. And then the housing market tanked with the crisis in 2009.
Mm-hmm.
And so after that, I couldn't find a job building houses for anybody. So I went into commercial construction, moved to Beaumont, and was an assistant project manager for that company. They had just been awarded 3 elementary schools. So learned a lot about, which actually helped me on the home building side. So I was learning about structural steel, terrazzo floors, commercial kitchen. So now if somebody says, hey, can I take this wall out? I'm like, yes, I know how to do that. I don't want to make it seem like, I'm nonchalant about it, but it's the experience, looking at steel base plates and stuff like that, that's helped me with that. I'm telling you that because that's kind of at the beginning of the rainwater harvesting business. At that point in time, my wife was expecting our first kid. She wanted to be able to stay home, and I wanted her to be able to stay home. So what I did was I needed to make more money to replace her income. So I started mowing yards after work. So I was a PM all day, and then I'd go home, put the lawnmower and the weed eater and the backpack blower in the truck and go mow a yard or two. And so then it grew. We hired a couple guys to help. And then I got my irrigator's license. And so that's the beginning of how the rainwater business started. So we started doing bigger projects, backyard, like blowing out the backyard with palm trees and stuff, and doing gas stations. And then the schools were finished. And at that time, residential picked back up. And so I went to work back in residential construction, worked for 3 other home building companies, and then was hired as the general manager of a home building company back here in Houston. So we moved back to Houston. I grew up in Spring. While I was in that position, we built our own house. Up in Magnolia, we bought an acre lot and cleared about half of it. And at that time, the business that I was the general manager for, we were doing a bunch of projects with Toner Kirstein with Toner Home Performance. So, of course, I was talking to him about my personal house, and he's like, "You should do condensate collection." And I'm like, "Well, I know what condensate collection is, right?" So that was starting to get implemented. Like, yes, this makes sense. I'm going to get 10 to 20 gallons of good, clean water for each AC system. But then I started looking at my house, and I'm like, well, how much water do I need from my irrigation system? Why don't I collect the water that falls on my roof? So what I did was I bought the textbook from A&M AgriLife Sciences, and using my irrigation background with calculating pressure, size of pipe, all that kind of stuff, I read the textbook and I taught myself how to do the calculation. So we were in that house we designed the rainwater system, installed it, connected to the irrigation system, and we were there for 3.5, 4 years. And I had to use city water 3 times. So that's the beginning of the rainwater business.
With population growth, which means demand on public utility systems, that coupled with like periods of drought that that we go through here, but then of course other parts of Texas, other parts of the country will experience much worse drought conditions than we do. But with all these things going on, but primarily here in our area, what we deal with is just population growth, and that's a limiting factor on what services the cities can provide. So, with all those things, it seems like that there's a big opportunity there for business, one, right, but also for helping people meet that need and kind of cushioning people against water restrictions and things like that, right?
That's right. We're meeting a need, but we're also solving a problem. So population growth is huge. The state of Texas is expecting the population of Texas to double in the next 20 to 30 years. So that's not that long from now.
And most of that's going to be in cities.
It's in cities. It's in the suburbs surrounding the cities. We're seeing it in Houston. The city of Conroe has a moratorium on building permits right now.
That's amazing.
Which is crazy. So that means that cities have to produce water. And so a lot of people don't think about this, but you just turn on your faucet and the water's there. The state of Texas is expecting the population of Texas to double in the next 20 to 30 years. So that's not that long from now.
And most of that's going to be in cities.
It's in cities. It's in the suburbs surrounding the cities. We're seeing it in Houston. The city of Conroe has a moratorium on building permits right now.
That's amazing.
Which is crazy. Cities have to produce water. And so a lot of people don't think about this, but you just turn on your faucet and the water's there, right? But cities are looking at what's the population. The city engineers are looking at, I've got this water treatment plant and it's producing this many millions of gallons of water a day. Now we're looking at population growth. Can we keep up with it? When do we need to start thinking about bringing on a new water treatment plant? And so that's where the city of Conroe is at right now, where they're like, we're at capacity. We cannot bring on any more homes or businesses because we literally don't have the capacity. We can't produce the water that the demand is calling for.
Right.
I've talked to developers about it. I talked to a volume builder earlier this week, and the city of Conroe isn't issuing irrigation permits. There's houses on the ground. If you're building a new house, whether it's a custom house in a neighborhood, you're probably going to you're going to have an irrigation system. It pretty much goes hand in hand at this point in time. And so now this builder can't put in irrigation systems. They won't give them a permit. Yeah. So we're exploring that right now as a possible solution to totally offset the need for water from the city for irrigation purposes.
And for people who are listening or watching, Conroe is a kind of a suburb, we'll say, north of Houston, another city about an hour north of Houston that's been growing tremendously. And there's 2 big lakes right there next to it. You got Lake Conroe and Lake Livingston that are both right there, and the river. So the water supply may not be the problem, but it's the processing of the water, it's the infrastructure to pipe the water, it's the pressure that's required to deliver the water. Mm-hmm. So people are like, oh, there's plenty of water up there. Well, yeah, I mean, the water's there, but it's the processing, it's the dealing with the water is part of the issue, right?
Right.
And Conroe is not the only municipality that's using that water. It's, they don't own that lake.
Right.
So they have their share of it that they can use. So there's a lot of, issues surrounding, cities growing, and how are they going to not only get the water but also process it. We're fortunate here in Texas that we have a lot of groundwater. We got a lot of surface water to use for the most part. We're not like maybe like Austin, West Texas, where they're dealing with very low water levels in lakes and things like that. But it's the infrastructure too that's just a tremendous expense.
Yeah. We're already drinking recycled water, and so people don't think about it. They depend on the city to produce that service. The sewer, the sanitary sewer, the storm sewer.
Yeah.
But all the water we're drinking is already recycled. All the water that goes down your drain goes back to the city. They filter everything out, and then they sanitize it, chlorinate it, and then they send it back to us.
Yeah.
That's where the pump station comes in, and they're sending the water back to your house, and then you drink the recycled water.
Right.
And so rainwater kind of goes and cuts that off, instead of taking the water and sending it to the city, and then they sanitize it and sell it back to you. You're collecting it at the source and using it at the source, which is your house or your business from the rooftop.
So, aside from just using the water, sorry, I'll have to start that thought over, Daniela. So aside from just just thinking about the logistics of how that water is going to be delivered, there's also just the cost of doing it. So when people are looking at doing these systems, they want to like offset the cost of buying that water. Like the city of Houston, I think charges $8 to $10 a gallon. Sorry, not per gallon, per 1,000 gallons of water. If you're in a mud district in Harris County, you might be paying $6 or $8 per 1,000 gallons. Other parts of the state and the country can be a lot higher. We're pretty reasonable here. So, by capturing and reusing this rainwater, you could potentially eliminate all your water bill associated with irrigation, or for keeping your pool filled up or whatever, right?
Mm-hmm. Yeah. So, looking at this at like the city level, the state level, and also looking at it as your own individual house, and like the price and what does this cost and does it make sense? If you take all the water that we use, all of us all together collectively, and it's coming from the city, where the city is sanitized it and sold it back to us, we use 59% of that water for irrigation.
Wow.
So here we have the population expecting to double, okay, in the next 20 to 30 years. Meanwhile, we're all using 59% of our water goes to water the plants, right? And so I'm of the generation where I'm going to drink from the hose. As a little kid, you go play, you go ride your bike, you drink from the hose. And then now people are like, no way, this has to be filtered, right? But looking at this from that standpoint, then it starts to make more sense. And I think that's where we can help solve that problem, where Conroe's experiencing it firsthand right now, where you've got population growth, you've got demand. You want the volume builders and the custom builders to come in and build the rooftops, so you have your tax base, so then you can provide those city services. But if we're able to come into a development, which we're talking to developers about, and implement these systems from the get-go, it does a couple different things, where say you design that water treatment plant and you keep it the same size, but now we put in rainwater systems on the new houses, and that statistic becomes more real, where 59%, just call it 50%, right? If you take 50% demand off that water treatment plant, you can either do one of two things. You can make that water treatment plant the half the size that you were expecting, or keep it the same size, and now it can supply twice as many people. Mm-hmm. That's where this starts to fit in on a much larger scale. Um, and then the other thing that it does is it takes the demand off of the storm sewer, right? And that's where detention comes in with City of Houston, but other cities are following what the City of Houston is doing or requiring, because now we've got huge population growth. It's not just residential. You've got to have, rooftops for businesses, for people to work in. Employers are coming in, building facilities, which is attracting people to Texas to move here because big employers are coming, which then turns into more impervious cover, which then turns into more stormwater runoff. So if we're going back and collecting the water at the different, at the source, which is the rooftop, then it's relieving the pressure off the water treatment plants. It's also relieving the pressure off the storm sewers. So it goes in hand like that.
Yeah. So for people who are in Houston, Harris County, we deal with this a lot. Although I know it's not unique to Texas, other parts of the country also deal with having some detention requirements if they're in a flood zone. But specifically here in Houston, you and I are used to, if we're building a new house in the floodplain, we have to have engineered drainage, we have to have mitigation, and a lot of times that means we have to provide water storage for our as part of that plan, basically. So we might have to be forced to put in effectively a storage system underground. It's designed to capture water, hold water, and then slowly release water into the city storm system to help fight flooding when a big rain event happens, right? And so I've had houses that we built that have had to have $40,000, $50,000, $60,000 worth of detention work, and that's not sexy money to spend, right? People don't want to spend $50,000 putting in a drainage system on their house when their budget's $1 million or less, right? So if we can provide kind of a benefit to that, you're saying, hey, you have to spend this money. Let's make it something that you're getting a return on now, right? And so, you've successfully done some projects where you've kind of coupled that mitigation requirement with a reuse system, and it's kind of a win-win. So it's like, yeah, you got to spend the money, which sucks, but now you're getting free irrigation water, and you're capturing some other benefits.
Right. Yeah. So what we've heard from other builders, from you and other custom builders, is you guys are working with the homeowner, right, and the architect, and through the process of developing the plans, they may not have been aware of, like, this is the lot I bought, this is the size of the lot, and so what ends up happening is, through that due diligence with the custom home builder and the architect and the engineer, is then what's uncovered is you're going to have to do detention, and you thought the project was going to cost this, and now one of you is going back to the homeowner going, so we're going to have to do detention. And then the homeowner says, what is that? And then they say, what does it cost? And you're like, you don't have a choice. This is going to be a requirement. Once we submit the plans to the City of Houston, if we don't design this up front, it's just going to get rejected. It's going to take longer in the permit process, right? And so then the home builder, the architect, the engineer explains to the homeowner, like, you have to do detention. This is what it is. This is what it's going to cost. And that's when
they freak out.
That's when they freak out.
It's a painful conversation.
And then the next question is, what other alternatives do we have? And that's when people find us. And so what Droplet Resources does is we design, install, and maintain rainwater systems and detention systems as a whole. And so it depends on the project. We look at each project individually, and we can combine different things that all surround water as a resource, as a really more like water conservation, right? And so you've got rainwater harvesting, you've got detention. And so the projects that we've done, if you're looking at meeting the detention requirement, then we're going to look at how many cubic feet of detention do you have to do. And then we can design a system that meets that requirement and also allows the homeowner to use the water. So then that sunk cost isn't just like seen as like, this is just like this giant tax that we got slapped with, right?
Mm-hmm.
Now there's a return on investment involved. And so not only can you reuse the water, but it can also have some other byproducts that cost savings that go along with it. One builder that we did a project for, they did a remodel and they did an addition, and it triggered the detention requirement. And so what the engineer designed was a giant manifold and 24-inch pipes that wrap all the way around the house where the gutters tie into.
I've done those. Yeah.
Okay. However, this lot had probably like 30 pine trees on it. And of course, the pine trees were also between the house and the fence.
This sounds like Memorial Villages.
It was Briar Grove.
Oh, yeah. It's close.
Yeah. Beautiful house, beautiful neighborhood. So what they were going to do is they're going to have to take the trees out. And so we calculated the system. What's the system going to cost? It's going to meet the detention requirement. And because of the way that the system is installed, we're not going to put in 24-inch pipe. We're going to put in 4-inch PVC pipe connected to your downspouts that take the water from the roof, through the gutters, through the downspouts, between the pine trees in the house. You're not going to have to lose these pine trees, which was going to be like $10,000 to take these pine trees out.
Yep.
And the system itself costs less than a company that was going to do just straight detention. And you weren't going to be able to use the water. So now we've saved them 10 grand. The system costs less than a detention system, and they get to use the water, and all their irrigation, the water they need for irrigation is all supplied by the rainwater system.
And I bet if you amortize that savings, let's say they save $20, $40, $50,000, they might have spent 20, 30, 40, 50, 60, 70 bucks a month paying for irrigation water. So now if you amortize that, it's kind of paying for itself essentially.
Yep.
Right.
Yep. So we can calculate, what's the payback period on the specific house, the project. And that's what people want to know is like, what does this cost? But then what's it going to save me? And so if you have a water bill, we can look at it, we can calculate it, and tell you what it's going to cost.
Yeah. How much water can you actually capture off of a roof? Is there like a rule of thumb for figuring out how many gallons of water I can get off of the average roof or off of my specific roof?
Yeah. So this is all a calculation. Everything we do is a calculation. It's not, this size tank will fit on the side of the house. So let's do that. The way that it's done is basically like a big supply and demand calculation. So we take rainfall data that goes back 20 years. I can look at it by zip code and tell you how many inches of rain or gallons, we convert it to gallons, is going to fall on your roof. And then we break it out by month because some months get more rain than others. And then the demand is, what do you want to use the water for? So most people go, okay, so rainwater, so irrigation, right? I'm like, yes, absolutely. And so we calculate from an irrigation standpoint, your outdoor demand. So we look at the square feet of sod that you have and what kind of sod, because what we're looking at there is what's called your evapotranspiration number. So that's the rate at which water evaporates, evapo, and then transpiration is the rate at which the plant or the sod uses the water. And so St. Augustine has a different ET number than Bermuda. It needs more water.
Yeah.
So we take that into account so that we're calculating the demand correctly. And then landscaping your flower beds, like what kind of plants do you have? Do you have native plants that need less water? And so then those two numbers together tell us what size tanks you actually need. And so this is strictly from a rainwater harvesting perspective, not a detention requirement. But so then what we've done on that project with all the pine trees is we calculated it both ways. To meet the detention requirement, we need this system to be this big. We need this many tanks at this size. However, I want to see if this is going to meet the homeowner's needs, right?
You might need more than what they're saying.
Right. And then it's super economical to just add another tank or make this tank a little bit bigger so that while we're putting the system in to meet the detention requirement, we meet your water demand for whatever you need.
Yeah.
And so that's outdoor demand, but then you also have indoor demand. So we can take all of this water and make it potable.
Nice.
We can take the same system and have one line coming off of the tank or the system of tanks and have it go to the irrigation system, right? It's non-potable water. It goes back to that 59% of all the water that the cities are producing is used for irrigation.
Yep.
Well, let's stop this at your house and not do the same thing. And so we can have one line coming off of the system to go to irrigation, and we have another line going off into your house and filter it, run it through a UV light to sanitize it, and then you can drink it. Whether you're in the city or you're off grid, we can do it wherever you're at.
And I'm sure that like some parts of the state, again, I'm thinking like Hill Country, West Texas, whatever, where it might be more like harder to hit a well, or more expensive to hit a well. For example, my uncle just remodeled his ranch house in Marble Falls. It's very rocky, very hilly, and the only place on the property they could hit a well was on top of a mountain a half mile away from the house. And it wasn't very cost effective, first of all, to get the equipment up there to drill, but then also to pipe it all down to the house.
Yep.
And so has a pretty good sized house with a good pitch and a standing seam metal roof, plus a barn with a metal roof. And so what he ended up doing was putting gutters on the whole thing, putting big tanks in, and he uses that water for all of his drinking, bathing, everything for his whole property.
Yeah, we could take different structures, like if like what you said your uncle has, combine it all into one system, or have separate systems if you've got livestock or whatever you need. The agriculture is also a big use for rainwater.
So he was going to spend $30,000 between drilling the well and piping it down to the house.
But then so what's happening also is wells are becoming not reliable. And so if you go back to that state level where they're saying the population is growing, the state is also looking at subsidence from a state level because of population growth. And so we've got more people moving out of the cities into the country. They're drilling wells. So are your neighbors.
Mm-hmm.
And then the next guy and the next guy, and everyone's drilling wells. And so the water table is going down.
Yeah.
And so there's really no guarantee from a well company that they're going to hit water.
Right.
They can go, well, the last well that I drilled for your neighbor, we went down 120 feet and we hit water. But then they've all been using that water collectively as a community. And so now it's becoming not reliable. And then you compare that to rainwater, and I can calculate how much water is going to fall on that roof every year for the past 20 years. And so it's more scientific. Also with a well, if you drill the well and you get water, great. You still have to filter it, right? So you can drink it.
Yep.
You got to make sure that you're not in a layer that, if you've got a bunch of sulfur, then you've got to add carbon to get rid of this, the sulfur taste and smell. So there's more to it than that. And so I think it's a more reliable source. And then with drilling wells, you're pumping the water out, and it's creating subsidence on a huge scale.
Yeah.
Where the ground level, like there are subsidence districts, right, that are looking at this, that are trying to warn the general public about the ground, the literal level of the ground sinking, which then from a home building perspective creates foundation problems.
Right.
So let's kind of think about this in reverse and look at other alternatives. And that's where
that
rainwater,
that whole part of the state where he is, like everyone's drawing from Edwards Aquifer. The whole city of Austin is drawing from that same source too, right? And Austin's growing like crazy. So what are they going to do?
So Georgetown is out of water.
Really?
They're like emergency mode. And so there's neighborhoods that don't have water. The city can't produce it, but there's neighborhoods of custom houses that don't have water.
like Lake Travis, Canyon Lake, all those major lakes in that area, their water levels got hit hard by a drought a few years ago, and they've never come back
Hmm.
because on top of the drought, those cities have grown like crazy,
Yep.
and so those lakes may never come back to where they were.
Right. Yeah, it's really crazy
And not
stuff.
to mention they're all downstream on the Colorado River from everything else going on,
Mhm.
up north in other states. So
There are 4 or 5 states that depend almost solely on the Colorado River for water.
I mean, water usage, water conservation is one of the biggest issues for growth for the country for the next decades. Probably on into the future forever. Like water is one of the top issues.
Mm-hmm. Absolutely.
So this helps do our small part toward helping solve that problem. Just a few more questions, kind of about kind of how this stuff works. Tell us like what the system consists of, like what components go into it. What's the footprint of it in terms of how much space on your property is it going to take up?
Yeah. So, I think if people in their minds, they're like, okay, rainwater, I think what they have in their mind is like a 55-gallon
Little drums on the side of the house.
On the side of the house that collects one downspout. And so what we're talking about is a system that's been planned on a much larger scale. That rain barrel is kind of the gateway, I would say, into rainwater harvesting.
Mm-hmm.
And so what you have, the components in the system are, you've got your roof area, you've got gutters on your house. The water goes through the gutters, through the downspout. And I mentioned it a minute ago, talking about the project with all the pine trees. That 4-inch PVC line, what we want to do ideally is collect every downspout. And so you've got 4-inch PVC connected to each downspout because the aluminum downspout that the gutter company put on isn't watertight. So we got to convert it to PVC. We can paint them to blend in with your house, make them disappear. So you're not looking at white PVC with,
Schedule 40
Schedule 40
on
on the side. That doesn't really look that great, no matter what kind of house you have. And so those lines then go down underground. They're all connected. They make their way over to the tank wherever it is. And so the tank can be above ground or it could be below ground. That particular project, it was an older house. They were doing a complete renovation to it. And so they wanted a new driveway. They also didn't really have a place for above ground tanks. So we did below ground tanks.
under the driveway.
Under the driveway.
Nice.
The builder demoed the driveway. And then we came in, we excavated, we put in the tanks. And there's multiple tanks because what they needed was 8,500 gallons of detention.
Mm.
And so we put 5 tanks, each 1,700 gallons, under the driveway. And then we need a place to get in the tanks for maintenance. We have a submersible pump in that one. And so we have a cast iron vehicular rated manhole flush with the driveway. You don't see it. And we positioned it right between where the tires, like right in the middle of where the car would roll over. So we're not trying to put pressure on it. And so you've got the gutters, the drain lines to the tank, and then you have to have a pump on it, whether it's above ground or below ground. You got to have a tank itself to collect the water. And then the way that the system works is it has a controller, and that controller is connected to your irrigation system, or it's connected to your house. And so that controller knows when you're calling for water. So in the case of an irrigation system, your irrigation controller is programmed. It's going to run zone 1 for 15 minutes. And so when that irrigation zone comes on, the controller tells the pump to turn on. What we also have in all of our systems is an automatic 3-way valve. And so that 3-way valve is connected to the city water line. And so there's a sensor in the tank that measures the amount of water in the system. And so we want to calculate the size of the tank appropriately in an ideal situation. But let's say that for some reason you use all the water in the tanks,
Or there's a drought.
or there's a drought, and so that there was a drought, you used all the water for irrigation or for potable uses. Now you're like, I don't have any water, right? And so that three-way valve, when it drops, when the tanks drop below a certain level, that three-way valve automatically switches you back to city water. City water then becomes your backup, and then it rains again, and the sensor says, "Hey, I've got water in the tanks," and it automatically puts you back on the rain tanks, takes you off of the city system.
Nice.
Yeah.
So I assume this is easier to do if you're building a new house from scratch, or you're kind of starting from scratch, and you're part of the planning process, right? Like we're planning out where the system's going to go, where the tank's going to go, all that kind of stuff.
Mm-hmm.
But also on a major remodel, again, like you're talking about, if you're tearing up the driveway, great opportunity. Mm-hmm. How do you deal with a house like an existing home where everything is not getting torn up? Is that still a possibility to come in and install a system?
Absolutely. And we're typically, even on a new house, we're coming in at the point in time where the outside's finished, the siding's on, it's painted, and the landscaping hasn't gone in. And so on an existing house, really the only difference is you probably already have landscaping. And so that's going to get disturbed a little bit. And then we're going to put it all back together. And then we work with some great landscapers that we can work with in conjunction. Maybe it's time to redo your landscaping anyways. But like we work, because of my background as a builder, we're already familiar with talking to architects and engineers and custom builders, volume builders, landscape architects, that are designing awesome, wonderful projects. And so, we can be part of that process in the beginning to incorporate it. Like what is this going to look like? Mm-hmm. There's different kinds of tanks. You can have a plastic tank. You can have a nice metal corrugated tank. What does the customer want? Do they want to see it? Do they not want to see it? What kind of restrictions, like, do they have a place for the tank? Right. Or working with like landscape architects going, let's put it on the side of the house. That's where I also want the electric meter, the gas meter, kind of build that utility yard, right? That's where we're going to put the generator. Let's put the tanks over there, but maybe you see part of the tanks from the backyard. So let's buy green plastic tanks, and then we can do a landscape buffer in front of it.
What about on houses that are elevated? Like, again, if you're building in the floodplain, sometimes that house is built up 3, 4, 5, 10 feet in the air.
Yep.
Or like where you live in Galveston, beach houses that are already elevated. Mm-hmm. What can you do under a house?
So there's different types of tanks. There's also pillows or bladders that fit in crawl spaces. So depending on how big that crawl space is, we can get a tank under there. Great. If it's only 4 feet tall, we can do a bladder, and it's going to work the same way as like a hard plastic or hard metal tank.
Okay. Yeah. Yep. We actually talked about a job that I'm on right now that I need to connect you with a homeowner. In fact, I just reminded myself I need to send that email to connect you. But it's a house that another builder recently did that we are back fixing some mess. And one of the things that they never got around to doing when they built the house, because they started running into problems with the build, they kind of put their whole rainwater thing on the back burner, but they've always wanted to do it. And so fortunately they had all the piping put in place for the most part. They just need to go back and get some storage installed. Mm-hmm. So, but their house is on a 6-foot crawl space. And so, yeah, great opportunity to use a bladder system to store their water under their house.
Yeah. So that's not a problem at all. It's just a matter of what storage tank or product is going to work best for each application. And then to answer your question about the elevation, that's where the pump itself comes into play. And so if it's, house in the heights and it's got a small crawl space, we can put a bladder underneath it, or the tank just sits on the ground on the side of the house. That's not a problem at all. But then if you're talking about like a beach house and you're trying to pump the water up, where there's really the first floor or breakaway walls, then you just have to size the pump correctly.
Yeah.
You've got to look at how much pressure
That head pressure that's to get it up there.
How much pressure is there, and we need the right size pump.
So again, I assume it's easier to get these things like if you're putting the tank in the backyard, it's probably easier to if it's a big tanks, it's easier to get them in earlier, right? But those things aren't super heavy, so if you had to crane them in, is that a possibility as well?
That's easy. That would be like a plastic tank. We could crane it in if we had to, or we're able just with manpower to get it in. Or if it's a metal tank, it's going to come in pieces anyways.
Oh.
We're going to build it on site. We're going to build a pad, and then like a corrugated metal tank. It's got rings. It's going to be built. It actually gets built from the bottom up. So you build the first ring, and then it goes up, and then you build the next layer, and then that goes up.
Is there a liner or something sprayed inside it, or what is it?
No, it's like a heavy duty plastic liner,
a bladder essentially that's been put inside the tank.
Yep. And so that's draped inside. Your corrugated metal tank isn't actually, the corrugated part isn't what's holding the water.
Yeah, that's just more for aesthetics, right?
Yep.
I think that's what people think about when they think about seeing a rainwater tank. They picture this corrugated metal thing with a little pointy top on it. Right?
Yeah, and so that just it's kind of like, what price point are you at? Do you want to see the tank? Yes. Can we screen it with landscaping? Yes. Or I want to show everybody that we're doing rainwater.
Yeah.
Or I just want something nice.
It can be more of an aesthetic feture, right? Or architectural feature of the property.
Yeah. I mean, so you see it commercially like Whole Foods, and they've got, a tank that's out in the front, and it's a nice tank because they want to say, hey, everybody, we're doing rainwater.
Yeah.
And so on the commercial side of things, corporations are now looking at their ESG number, environmental, societal, and governance. And so they're measuring their ESG number. They've got an ESG officer, and they're going, all right, well, how sustainable is my company? And so now it's kind of like looking at your carbon footprint, but it's like your carbon footprint for your company. And so companies that are looking at that also want to, I'm building a new building for the office, for our headquarters, right? So we want it to be sustainable. We want it to be LEED certified. What are the different things that we're looking at? And so ESG is becoming more of a thing on the commercial side. So
aside from just capturing rainwater, what other types of water can we capture and reuse? So one thing that we've talked about on other episodes of the podcast, I think with Toner and some others, is capturing air conditioning condensate. Because a typical just one AC unit can be 10, 20 gallons a day worth of condensate that thing's putting out, right?
Yeah. So in areas that have 60 to 80% relative humidity, which Houston, we all know Houston is humid, right? Each AC system is going to produce 10 to 20 gallons of condensate a day.
Yeah. And if you have a big house that has 3 or 4 AC units,
right,
that's a lot.
Yep. The other way to look at this from a different perspective is looking at your tonnage. So if your AC is a 3 ton, a 4 ton, 1 ton in the same area, 60 to 80% relative humidity, you should expect to get 600 to 800 gallons of condensate per ton of AC a year. So that's another way to break it down.
Yeah. And so if you've got 3 or 4 AC units, and now like we've talked again on this podcast, we've talked a lot about different heat pump options that are out there, like heat pump water heaters, heat pump clothes dryers. All those things are working like an AC works. They're producing condensate. Plus you got your dehumidifiers. A lot of houses we're building now have dehumidifiers. You combine all these sources, you can be putting out a significant amount of water on a daily basis.
Right. And so we can take all these different sources, we can combine them. That's where we ask homeowners, what do you want to use the water for? right? And so we can combine them all into one tank and then have the water go, just irrigation or irrigation and potable. Or we can keep them separate depending on what the reason is. And so a couple of years ago, we did a project for a builder in Sugarland. The homeowner is an EPA lawyer, and so he's into all this stuff. And they're building this. They built this awesome house, and the homeowner wanted it to be the first LEED platinum house in Fort Bend County. And so that's how we got introduced to him. Was they've got to do literally everything on the checklist. And so they were also, with Rainwater was on the checklist. And so Toner was consulting on the job, educated the homeowner on condensate collection. They're like, this is super cool. They also built a pool while they were building the house. And so what we did for that project was we kept them separate. The rainwater went to tanks, went to their irrigation system, their condensate went to a separate tank, and we worked with the pool contractor to make it the auto fill on the pool.
Mm-hmm.
So if you think about it, as the water is evaporating, it's the hottest part of the year. It's also when your AC is producing the most amount of condensate.
Yep.
And so condensate is super clean water. It's virtually like distilled water.
It's like pH neutral. I was reading. It's like 6 to 8, which is right in the middle of the scale.
So because of that, when you put it in your pool, it doesn't jack up your pH balance.
Mm-hmm.
If you use city water, you're running the hose, right? Or you've got the autofill on. You're like, hey, I need to add an inch of water. Now you got to go back, check your chemical balance, and go, oh, I got to shock it. Oh, wait, I put in too much chlorine. Now I got to add muriatic acid. Right. And so that was really fun to do.
I bet.
Yeah.
And also the condensate water is cold. It's very cold coming out of your AC system. So during the summer, if you're putting that water into your pool, helps maintain your water temperatures on your pool as well.
Mm-hmm. Yep.
So let's talk about like any potential issues dealing with cities, HOAs, things like that. One thing I was reading is that Texas actually adopted into the property code something that's basically protected the rights of homeowners to install these systems.
Yep, that's right. Yeah, it's in the property code. This is one of our frequently asked questions on our website, and it says, can an HOA restrict me from doing rainwater harvesting? The answer is no. So they may be able to restrict like what kind of tank, what does it look like?
Placement, yeah.
It's kind of like probably like a shed in your backyard, depending on whatever your HOA says. But what it boils down to is they can't stop you from doing rainwater harvesting.
Mm-hmm.
And then another thing similar to that is in Texas, components of rainwater systems are sales tax exempt.
Oh, nice.
Yeah. So there's things that are coming that are starting that are helping make it more affordable.
Are there any tax credits available yet?
So it depends on what city you're in. Like Austin, I know they had a program. We're beginning conversations with the city of Houston. I've got a meeting coming up with the city engineer to talk about rainwater. They want to do more sustainable things.
It seems
and promote it.
It seems like the state or even federal level would have some kind of incentives out there for tax purposes, for this type of thing.
Yep. But I know the city of Houston wants to do this kind of stuff. They want to promote it. Their communications department has reached out to us, and we've got a meeting coming up with the city engineer to explore this more. And one of the things that I'm going to be talking to him is we need incentives. I think what it boils down to is people, they either want to do it, but I think it's I need to do it or I have to do it. So like I'm building a house, I have to do detention. What other alternatives are there? And so there's that, the need, and that's where we come in and we can meet the need. But I think it would definitely help if the city has some kind of incentive to literally incentivize homeowners to put these systems in that are interested in it, that might be on the fence for some reason, and then they have an incentive, like a tax credit, um, or money off their water bill for a certain amount of time. Like there's a bunch of different things that we can explore that helps move this along for everybody.
Yeah. Last couple of things I wanted to touch on. One is maintenance. So I know that you mentioned that you guys do maintenance on your systems. What kind of maintenance is required on these things? And I know it varies based on what you're using it for. Because if you're using it for potable, then you got all the filter stuff to deal with, right? But
Right.
what types of maintenance is required on each type of system?
So we design them, we in systems, we install the systems, and we maintain the systems. And so what we set people up on the maintenance program is quarterly maintenance and annual maintenance. And so the quarterly visits are to check the system, make sure it's working properly, do a visual check, clean out the downspout filters. Um, and when we're doing that, we're always checking the controller to make sure it's working properly. Is the three-way valve in the correct position? If we simulate the tank system running out of water by removing the sensor from the tank, does it put it back on the city side automatically? And then looking for components of the system itself, like the bulkhead fittings. Are they leaking? Are they cracked? Depends on how old the system is. And then the annual maintenance, which is then just happening the next quarter, includes that entire checklist of the system itself, but also cleaning out the tank. And so your gutters, we either need to have a filter on the gutter, like a leaf guard, or
a good quality one, I assume, because there's different levels of that
you
stuff.
need a good quality one, or we put a filter on every downspout. So when if we're converting your aluminum downspout to a PVC downspout, we're putting in like an inline filter, but it's a huge filter that has a cover on the front that you can lift up.
You can lift it up and pull all the junk out.
You can pull all the junk out. It's a stainless steel filter, and so that comes out. We clean it off. We wash it off. But then we drain the tanks. And so all the sediment settles at the bottom of the tank. That's where it ultimately goes. We want the filter on the downspouts or the gutters to filter out the bulk of the debris. And then all the fine particles are going to make their way through the system into the tank, and they're going to settle at the bottom. And so we drain the tanks, and then we remove all of that sediment, and that prolongs the life of the entire system.
I bet there's a lot of granules, like if you have a composition roof, right? Like a lot of roof granules that make it through there.
A little bit. A lot of those get taken out by the downspout filter.
That's good.
And then it depends on like what's above your roof. If you've got 30 pine trees, you're going to have more sediment at the bottom of the tank, because like pine trees have those pollen buds that turn to dust that make just like a sludge at the bottom of the tank, which is not a problem because the way the system is set up, we're not pulling the water off the bottom of the tank. You have what's called a floating extractor. And so that line that goes to your pump is connected to a hose inside the tank that has a ball that floats on the top level. And so as you're using the water, that ball is keeping that suction hose at the top. And that's, if you kind of look at the different segments of the water quality in the tank, the best water quality is at the top. And that's where we're sucking the water out of.
Is there one type of roof that's better than others? Like, is a standing seam metal roof inherently better for this than a comp roof?
They all work the same. It's kind of good, better, best. And so a composition shingle roof is great. Metal roof is better. But it doesn't really change the system at all.
Yeah.
I mean, you may get fewer granules, but all the leaves and all the pollen and everything that falls on a metal roof is still going to make its way through the system. The pitch of a roof doesn't matter. You can have a 812 and it doesn't matter. The rain doesn't care what it falls on,
Right.
essentially. So like we're looking at the footprint of the roof.
It's the area. Yeah.
It's the area. It is. That's the calculation.
How do you deal with freezing concerns and winterization?
Yep. So the area we're in doesn't really freeze. We're not in a freeze prone area. Below ground tanks do better.
Yeah.
Because it's warmer underground. And so most systems are not underground. Most systems, you've got tanks above ground on the side of the house, in the backyard, in a crawl space. And so ideally, what you want to do is if you're going into a freeze, then you don't really want your tanks more than 3/4 full, because when water freezes, it expands.
Yeah.
Right? And so that's the biggest thing to be aware of. And then if you've got a controller and a three-way valve during the freeze, you want to make sure that they're still running. It's kind of like dripping your faucet, where you don't want to shut it down. You want to give water room to expand so that it doesn't crack pipes and crack the tank. And then after the freeze, you need to do an evaluation and see if anything did break.
Yeah.
Just like your house.
Yeah. Okay. Cool. All right. So last thing, and I think this is one of the really the most exciting and interesting things that's not related to how we are using the water here, but is talking about how these systems can potentially impact and be a big benefit in developing countries. You think about areas that don't have access to clean water throughout the world, whether that's Africa, South America, wherever, right? Even in the U.S. and communities that don't have access to good clean water, right? But I know that you've been involved in doing some work in Kenya. Is that right?
Yep.
So talk to us about what you're doing there and kind of what you think those opportunities are for other parts of the world that need clean water.
Yeah. So the church that we're members of, we give to different nonprofits. So when you tithe, then a portion of your tithe goes to different nonprofits that our church supports. And so one of those is Segera Mission in Kenya. And so we know about Segera Mission. We've known about it since we joined the church. And so our church goes on a mission trip every year. And the director of the mission goes to our church. And then, so last summer, or kind of before that, the director found out that I have a rainwater harvesting company. And at that time, that area in Kenya was going through the worst drought they've had in 50 years. And so we started talking about it, tell me about the mission, like the actual like day-to-day problems, like, who does the mission serve? How much rain does the area get? Like, is this a possible solution? And so last summer, I went to Kenya at the same time as our church mission trip, which was super cool, great experience. And I was also there to see if this was a real solution for the mission. And so the mission started 20 years ago by a retired pastor. He went there, he fell in love with the people. They're all super joyful. It's really amazing. It kind of takes you out of your American day-to-day, I have all the things, I'm in a hurry, I have to get, whatever, and like unplugs you, and kind of takes you back, just puts different things in perspective. And so when the mission started, it was super small. The population of that area was maybe a few thousand people. And so this is way out where there's no city water, city sewer, right? Like to get there, it takes a day from here. So you fly through Paris, you fly into Nairobi, and then you get in a Toyota Land Cruiser for 5 hours to go through Nanyuki. Nanyuki's the last city that's got like a grocery store and power and water and sewer. And so then you go out and eventually the road ends and you get to Segera Mission. And so the mission has grown. It's 5 acres. And over time, the mission has grown to have a school, um, a hospital. It started as a clinic. Now it's turned into a hospital, has a sonogram machine. It's got a staff. It's got doctors. Um, and so because of those services, the population has grown. And so people in the area depend on the mission for services. Like you get sick, you walk 5 miles to Segura Mission to go to the hospital to get checked out. If you need clean water, you go to the mission. And so now the population is 20,000 people.
Wow.
And this
Huge
little mission, and they have a staff. And so they're a nonprofit. They're a 501c3. And so during this mission trip, there's people from the church there. They go out to different villages during the day, and there was a couple doctors on the trip at the same time. And we're sitting around the dinner table that night, like we did every night. We're like, "Hey, what'd you do today? Oh, we went to this village. Oh, we went to the market. They have a market. That's how you get groceries once a week." And so you'd go and experience the market. And so I was there to see if this is a possible solution. So I'm measuring buildings and talking to the staff. And I remember the night that this kind of all came together was the doctors are talking about their day, right? So they've been there before. They're there again to see, we're doctors in Houston, right? So let's take the systems and processes and teach these other doctors like how they can do things better, what do they need to be looking for, what kind of services they need to provide. And when the mission started, the infant mortality rate was 35%.
Ooh.
Okay.
Wow.
Now, because the clinic has grown, they got a sonogram machine, they've got doctors, the doctors are getting trained. The infant mortality rate is now less than 1%.
Dang.
It's crazy.
Yeah.
So I think that's
awesome.
less. I think that's less than the United States infant mortality rate, infant and maternal mortality rate for pregnancies and deliveries.
No.
And so they're talking about that, and what they're talking about is there are, when they were there and they're looking at what are people being admitted for, a lot of gastrointestinal problems, which is then giving people hepatitis A and E, so we're sitting around the table and they're talking about this, and they knew why I was there. And so, they're like, there's just so many people are trying to figure out, what's going on. And I said, Dr. Hommel, like, what causes that? And she looks at me and she goes, bad drinking water. And I'm like, oh my God, like literally.
Yeah.
I'm like, I know why I'm here. And I can actually do something about it. So Houston gets 50 inches of rain a year. That area of Kenya gets 50 inches of rain a year. It's just different because it all comes at once. They have the rainy season. And so we just have to look at systems differently. We have to look at storage differently. The systems are essentially the same. And so they have 5 acres. They have plenty of room for tanks. And so people depend on this mission for water. However, looking at what the doctors found, they don't have good drinking water. And so when I was there, I'm measuring buildings to see like what's the capacity and stuff. But I'm also interviewing the staff going, where are you guys getting water from? And so because of the drought, that was the worst drought they've had in 50 years, they didn't have any water. They're like, what do we do? Let's drill a well. And so all the trees died, all the acacia trees, which are like native. That's what you typically think of, like, looking at the Sahara, it's an acacia tree. So they all died, which totally changed the landscape. But then they replanted the trees. They drilled the well so they have water to drink, and they replanted the trees. And so they replanted the trees, and then they started using the well water to water the trees. And guess what? the trees died. And I'm talking to the staff and I'm like, okay, so you have well water. And they're like, yeah, but we don't like it. It's super salty. Okay. So the well water, yes, it's keeping them alive. It's solving a problem. It's giving them water to drink, but it's making them sick.
Yeah.
It's super self-evident by killing the trees, right? Let's replant all these trees and then the trees die. But what they don't realize is it's making them sick and it's overloading the hospital, right? So here we are with this opportunity where they have 14 structures on the 5 acres of the mission. And so this is what we're doing. This is what Droplet Resources is doing is we're going to start putting systems on these structures and supplying good drinking water to Segura mission and the 20,000 people that depend on the mission. So huge opportunity. So we need to raise the funds to do it. They're a nonprofit. It's a 501c3. Any money that is donated goes directly to the mission. They don't have a bunch of different layers of like middle management or overhead that like takes up that huge donation. That money goes straight to the mission and then it's able to like get deployed immediately. And so I already have plans to go back in June. And so we're raising funds now to do phase 1, which are 3 houses across the road. It's a dirt road outside the gate of the mission. Those 3 houses are staff houses. And so that's the first thing we're going to do is put systems on those 3 houses. They're more of an American style house. You know, it's got a hip roof with, we're putting gutters on it. And then it's an American style house, but Kenyans, a lot of people live in each house. So there's like 6 to 8 people that live in each house. And these are like 800 square feet houses. So those systems are going to get installed. And then the overflow from those systems, we're making those potable systems. We're trying to drink this water. The overflow is going to go to another tank that's going to be a community tank at the road. And so what people have to do now is walk about 5 miles a day to the mission to get clean drinking water. And right now, the way it's set up is to get clean drinking water, even though it's the well water that's not the best, they got to walk through the gates of the mission and down around the corner to get to the pump. But these are kids. Like, this is not like dad is a shepherd, a literal shepherd. Mom's taking care of the house, and the girls are the ones. It's not the boys. The boys are learning how to be shepherds. The girls are the ones walking 5 miles a day with a bucket, a recycled O'Reilly's oil can that's been washed out 100 times. They're the ones that are walking. And so what we're trying to do is shorten that walk, give them clean drinking water. So that's phase 1. Phase 2 is the hospital. So we're going to be putting a system on the hospital with all the same things that we talked about, and then keep going. And so we're getting into the holidays and a time when people give and donate. The Tuesday after Thanksgiving is Giving Tuesday, right? You got Cyber Monday, you got Giving Tuesday. And so what we have on our website, if you go to dropletresources.com, you'll see the different things we do, you know, residential, commercial, maintenance, frequently asked questions, and then donate. And so if you go there, it's going to take you to that page. And that page goes directly to Segura Mission's donate page. And you can donate directly. You can set it up where it's like one time or every recurring, whatever. And there's a drop down menu that says general or water. And so we want you to click water. So that way your donation goes to Segura Mission. To the director is going to see it. And then he and I are gonna, he's gonna say, hey, we have this much, which means we can do phase 1, or this much has been donated, so we can do phase 1 and 2. And so that's what we're implementing now, to go back in June and start the first 3 systems. And then going forward after that, what Droplet Resources is committed to doing is, for every system we install in the greater Houston area, we're going to put a system on a house for a Kenyan.
Wow, that's amazing.
Yeah.
Man, that's so awesome. So we will absolutely put a link on our podcast show notes and the reels that we post about this, to where people can go straight there and make donations. And we'll also, we always do some promo reels and stuff for this. We'll dedicate some of those to help spreading the word on this, and hopefully get the word out for that cause. Because that's amazing work that y'all are doing.
Yeah. Thank you very much.
Yeah, I'm really excited about that. Our church does a lot of stuff in Kenya as well, and so I'll talk to one of our team that works with that group and see. I don't know if they're in the same area or not, but see if they are, and see if maybe there's some synergy there as well.
Mm-hmm. That'd be great. Thank you very much.
Man, I'm so happy to hear what you're doing there. That's great work.
Yeah. Thanks, Curtis.
Well, Zach, I really appreciate you being here today. It's, like I said, this has been a topic that I've been wanting to hit for a while, and I'm so happy that you came and joined me.
Yeah, me too. Thanks a lot. Appreciate it.
And so we'll be sure and link all your info, but just give a shout out to your website again and your social media and all that kind of stuff. And we'll also link it as well.
Yeah, it's dropletresources.com, and we're on Instagram as well at Droplet Resources.
Awesome. Yeah. All right. Well, thanks, Zach. Good to see you as always.
You too.
And we'll
Thanks,
see you
Curtis.
soon. And thank you, everybody, for listening and watching the Your Project Shepherd podcast. I will see you next time. Bye-bye.